is understand what is exactly the big data is all about. What are the different concepts involved behind it? So first, once we understood those, then gradually, slowly, we'll move to the the latest tools and technologies that we are working. But first, we need to understand how it evolved, why we need this big data and all. So last time also, like what we I just told you so few of the things that we are going to repeat again, and then we'll move further, right? And
Okay.
yeah, you can just let me know wherever you feel that you are not able to understand any of the concepts, or it's going over the head. Just you can just stop me, and feel free to ask any questions wherever you find like, okay, you need to go into
Okay.
more details of it, right? But
Okay.
because these whatever we are going to study in first couple of sessions, so those mainly going to work behind the scene as of now, because most of the things we need to understand, and based on that, the new technologies that come. But those are getting used behind now. Now they are the things, those concepts are not upfront, and might be those are not going to be directly used, but yeah, indirectly, even whenever we are working in the industry, so we are using them, right? So all the even the latest tools and technologies that we are working, the concepts behind them is the same that we used earlier, right? So let me just share my screen, and then we can get started.
Okay.
Let me know once you are able to see my screen.
Yes.
Okay. Yeah. So today we'll be, we'll try to understand what is big data, what are the limitations were there as a part of our existing data solutions at that point of time, and then understand what is Hadoop and its features, Hadoop, what was a Hadoop ecosystem, and we'll try to understand Hadoop 2.x. Although like there were Hadoop 1.0, then 2.0, still 3.0 come, but it was not as popular as, because when 3.0 came at the same point of time, basically the Spark came. So that's why it shadowed Hadoop 3.0. It got shadowed by the Spark itself, and then we see how the read and write happens as a part of Hadoop. So these kind of things we'll try to understand today, and we'll try to cover as much as possible.
Yeah.
So let's start with this, right? So as we already discussed, what we are calling as a big data. So when we are talking about the data in terms of terabytes and petabytes, lots and lots of data, huge amount of data, and data nowadays it's coming from different data sources. So what if we talk about in terms of if we have to define the big data? So when we say like the data which is not possible to be processed by the traditional database tools, where those traditional database tools or applications got failed, then this big data term was coined, that okay, whenever the data is going to be too complex and big, that it becomes quite difficult to process using all the data management applications or traditional applications, then we are saying it's a big data. So mainly, if we talk about what kind of challenges that we are facing as a part of processing, or so how we are going to capture it, how we are going to maintain, curate it, then storage, searching, sharing, transferring, doing a lot of analysis and visualization on top of it. So the traditional tools here got failed when we talk about in terms of data that we were getting as a part of terabytes and petabytes. Like even let me give you the real time scenario that still a lot of organizations are facing. So few times back we had the merger with this DHL. So now the DHL, what as you know, it's a very logistic, large logistic organization which is having their operations all over the world. So now when they got merged, now they have got their data in terms of terabytes, petabytes of data, and they used to have the everything. If I just talk about the reporting part, so they used to put their reports in Excel formats, and now because of the huge data and operations, managing those reports as a part of either Excel or they were using some sort of tools to process those reports and showcase them to their management. It was quite difficult for them. So now what we have suggested when they come to us, now we have suggested them, like instead of processing them from their traditional systems, they were using some even databases, some SQL databases that they were using, but still when they were able to do it up till 100 GBs of data. Even some of the reports I saw having different images too, and a single report is having around few GBs of file. So processing those files was taking longer as expected. So what we did is, like, we have moved their system to Databricks itself. Now we have just showcased and did some POC to how they are going to migrate their report from DHL to Databricks, and once they have got migrated to Databricks, so they were able to use the Power BI from there itself, and building their reports on it. And from the report perspective, it was quite concise as well as clear to the management also. So they were able to build. So now they have started migrating their reports. Apart from this, they have their reports in the form of cubes, and cubes, if you have got the idea on this, so it's basically Oracle storage format, where one of the reports can be around even in 10 GBs, 20 GBs. So in the form of cubes, even larger, more than 100 GB of reports can you develop using this cube format. But when it comes to processing those using traditional systems, is what those were facing a lot of issues. So this was just to give you the background that how traditional systems were failing. And I'm just talking about few GBs of reports. But when it comes to big data, we generally talk about the data when we are going to deal with terabytes and petabytes, because in traditional systems also we are having some of the data which can even process up till 20 terabytes of data. Like if you have heard about exadata, teradata. So even now we are using terraforms also somewhere. So but now it's previously it was used for another purpose. Now the Terraform, they have just come up with a lot of advancements, and now it is also used for orchestration kind of things. So yeah, now it's better. But yeah, if we talk about the let's say 10 years back, 20, 15 years back, so those were having a lot of issues. And you can just stop me wherever you find like, okay, this is this thing you are not able to understand. So basically the things comes like how we are getting this data. So basically there are n number of we can say the sources are there from which we are basically generating the data. So like we from the sales, like ERP systems are generating huge amount of data. So you can say like Amazon handles more than 15 million customer clicks per day, but it's quite you can say the slide is quite old. So, but if we talk about the today's world, it's not 50 million. It's more than a billion, per day. User clicks are there wherever we are, storing. Whenever a new user comes up or clicks on a particular link, a data has to be stored from where the data is coming. So every information of that data is getting stored in some form, like whatever the the location of the user is there. If some form is getting provided, so whatever the information that the person has put, so all those informations are going to be stored. Then similar is ways for the the now huge number of peoples are there as a part of stock market who are investing in the stock market. So their data as well as trading data on daily basis. So more than few terabytes of data is getting generated on a single day. So you can imagine, like when we are going to process, or when a particular person wants to uh, wants to do any sort of trading in the stock market. So how you are going to decide which stock you have to work upon. So even for, let's say, if we are generating 1 terabyte of data on daily basis, so it's not on the basis of a month or few days. We are going to decide, okay, we have to get this particular product. We have to choose it by seeing its history for the last 10 years, 20 years, 15 years of trading pattern, or when it got started. Let's say it got started in the last 5 years, and how it is performing. So similar way, like, so when we have to decide something, and when the latest tools and technologies, or the you can say applications, how they are processing that data. So they are not processing for last 1 month or 1 year of data. Let me just give you, because we are also building this one application, what we can say, one product we are building for stock market retail, retailers for US market itself. So there we are processing the data. We are, we are storing the data since 1990 back. So now you can think from 1990 onwards to 2025-26, like last 35 years of data that we are going to process to get the analysis on top of it, so that the new users can get the the real insight of the data. And they based on that, we are also going to give them recommendations, which stock is going to be, you have to buy today, or you need to sell it today. At this point of time, you have to buy and sell. So those kind of recommendations, how we are going to generate it. So once we have to get the data, we have to analyze it. Once we are going to analyze it, based on that, we are putting a lot of models on top of it, using the data science models, then using the AI, basically generative AI concept nowadays, and making our clients so that they should be able to take the good decision. So they should not have got any sort of like loss whenever they are going to use our application. So this is not our motto. This is everyone who is working on building their products. So until unless if some user is coming to us and they are not getting benefit out of it, so nobody is going to use our application. So similar case, we are having, like emails are getting sent more than 1 billion emails are getting, more than 1,000 billion emails are getting sent nowadays, because everybody is using from the internet. And now the AI has come. If you talk about, we can talk about the social media. Social media also is another area where a lot of data is getting generated. So we have got the sources, if we talk about, and from where we are getting the data. So we have got social media, where we are getting posts, tweets, likes, shares. We are doing a lot of things. Then IoT sensors are there, where every device nowadays is a smart device. Weather forecastings are there, then industries are using latest machineries. Everything is getting every machine is basically recording what the machine is doing. Let's say I've given you last time an example, like whenever a flight is running, so a particular a plane is having more than 600 sensors out there, which are basically getting the information on each flight. So more than 1 terabyte of data is getting generated from one a flight only. So to measure different parameters when a flight from the start to when it take off to landing. So huge amount of data is getting generated. Then again, if we comes to the the financial domain, so a lot of business transactions are getting happened on daily basis. Either it's going to be credit card, e-commerce purchases, a lot of data we are generating on daily basis. Then if we talk about public records are also there, government has their own data, weather reports, and a number of things are there. So from that we are generating huge and huge amount of data. So what we are going to do with this data? Until unless we are not going to process it, there is no use of data. So nowadays we have this thing like now data is a new oil. So everybody, if you have got the data, and you can tell anything about that particular person. Like if you have got the let's say last 1 year or 1 year chats for a particular user, so you can even tell him what about his behavior, how it's the person's behavior is changing, what kind of person he or she is. So those kind of things we can definitely get it by having the data. So nowadays a lot of psychiatrists basically study the human's mind based on the how they are reacting. So those kind of studies, and where what we are doing is we are just playing with the data. But to get all those insights we need the data. So basically we are generating billions and trillions of terabytes and gigabytes of data on daily basis. So the main thing comes like how we are going to store and process it. So, and whatever data we are just generating, previously we used to have only the data in the structured format. Like if you see, this is still 2025 15 graph, but now this graph is basically as you can see it's exploding in terms of the data size that we are getting. So in 2005 you can see we generally have the structured data, very less amount of structured and unstructured data. But as you see, the graph is growing. Structured data is also growing, but structured is not growing in that much volume as the unstructured data is growing. So processing unstructured data is again it's a huge task, because if we talk about the traditional systems like you can talk about any of the SAS, Teradata, Oracle, or SAS, or any of the MS SQL Server, they are not able to process unstructured data. And if you have worked, or if you have worked on any of the traditional systems so far, so you must have got this idea that processing unstructured data using traditional systems, it's not an easy. We can process structured up to semi-structured data like JSON, XML format is there, that we can do. But when it comes to audio, video, and human readable text, there these traditional systems are actually failing, right? So again, as I told you, this was the definition of the data which was given by the IBM initially. So they have just come up with this three V's initially, and then they have added one more V, the Veracity, and finally a new V has been introduced, which is called, what is the I think last time we discussed this thing, right? So if you remember,
Value,
yeah,
value.
Yeah, the value, right? So volume, as we know, that the scale of data that we are generating in terms of terabytes and peta. So it's basically going in exponentially. We are growing the data on daily basis. Then again, velocity. So
There is a pop-up on the screen. Can you please hide on that? Meeting, stop sharing the hide.
Yeah, even I was trying that.
yeah, usually you can just tell me, right?
Okay.
Okay, so the data that we are generating, huge amount of data in terms of terabytes, petabytes on daily basis. So to process that, if we are generating the data at huge, so we have to process it. Because if we are not processing and only generating the data, then there is of no use, right? Because now, as I told you, data is a new oil. So who can mine it? Mining means like processing the data, getting the inside of it. It's really necessary. Then comes the variety. Like we are not generating only structured data. We are generating data in different structured, semi-structured, unstructured format. So that data is coming from web logs, audios, videos, sensor data, as I told you. So these are generating data in different formats. So there is a variety of data that we are getting. Then veracity is basically the uncertainty in data. There is no trust. We don't have the trust in the data itself. It's totally uncertainty of the data is there. Whenever, like in structured format, generally we get the data in the form of uh, rows and columns. So in terms of tables, so there we can go and check. And because what we are doing is like when we create a table, so before creating the table, we define the structure of the table, right? Like, okay, this is going to be the table, this is going to be the columns, and within the columns itself, these are going to be the data types that we have to specify, and then we are going to load the table. But when it comes to unstructured data, so defining the structure at the beforehand, it's not going to be possible. So such kind of data, again, processing using traditional systems is quite tough. So basically, when we are talking about the definition, so definition means like when we are saying big data. So big data is not the solution. Big data is the problem actually, right? So whenever the volume of data is quite high, velocity, the data is getting generated as a very high speed, and we are having variety, different forms of data. So if processing this kind of data, it was a quite mess with traditional systems. So that's why big data is a problem. It's not a solution. Then they have come up with another thing like, okay, whatever data we are getting, that's not trustworthy data. It's not there is no certainty in data. Like where somewhere we are getting huge amount of data, and sometime for the same, let's say for this example has been given for a particular year, the minimum, maximum, mean, and standard deviations are given for a particular matrix. But for certain year, we don't have any data. So there is no certainty. So these kind of data, again, processing using traditional systems is a big mess. So they have also added veracity of the data as a part of definition of big data. Now they have come up with the another V, which is called value. So value is the basically until unless you are not able to get the meaningful insights from the data itself, what is the use of that data? So that is the our ultimate goal. We are processing it. Why we are processing it? Because we need to get the turn that data into fruitful results. Until unless we are not able to do it, so that's why that V has also been introduced, and that is one of the main V as a part of this definition of big data. So now we are having these V's are there, although they are they have added few more V's, but these are the 5 V's generally we define as a part of our definition of big data. So now, as I given you, there are different scenarios are there where we can have this big data is basically getting used. So let's say recommendation engines, you must have see like now for any sort of product that you are getting, there are a lot of recommendation engines which gives you the same sort of ads, or like if you have click on a particular link, product. So every time, next time you are going to get the similar ads or recommendations. Then whenever we are working, let's say I have got search quality is going to be increased when we are going to have the larger pool of data. So definitely my search quality is getting increased. Now you can see we have got search engines like Google is going to bring you on just a single click, you are going to get huge amount of data from the cloud itself. Then when it comes to, let's say, nowadays it's quite obvious in the form of financial services, where this fraud detection is getting peoples are getting protected from the fraud detection. So basically banks and financial institutions, they are using real-time analytics for instant fraud detections. So they are running different trading algorithms, or they are using anti money laundering efforts. So how they are doing it? So they do it by analyzing transaction streams and make their systems instantly going to uh, uh, give you or going to block the suspicious activity. And they generally what they are doing, they are basically reducing the risk and the operational access to that. Like nowadays, like a lot of people are getting these kind of fraud calls, and now you see whenever you are getting a calls on your phone itself, we used to get it like, okay, this is a fraud call, it's a spam. So at least like people have got the chance to understand, okay, this is going to be a suspicious call, and we should be take care of all those things. So similar issues can happen at the same point of time. Even I'm not saying now, but yeah, few times back I also get a call from the from the bank itself, like, okay, somebody told me like, okay, you have did some transaction on your credit card in Mumbai itself. But I was there in the Delhi actually. So before I got this call from the bank, like you did some transaction from your credit card. So I say like, no, I didn't do. I just made a transaction of 5,000, but somebody was trying to make the transaction in Mumbai. I was in Delhi, but I don't know how it happened. But they were trying to do this similar transaction in Mumbai itself, like after within a span of just half an hour. So they, from the location itself at the runtime, they tracked my card usage and give me a call to check whether I am the user who is doing this transaction. Like before doing the transaction, they just asked me whether I am the correct person who is doing the transaction. So I thought like, no, I didn't do that transaction. I'm not doing that transaction. I just did it half an hour back, and I did it in Delhi. So that's why they stopped that transaction. So it was some sort of fraud is happening. I don't know how it happened. Somebody has cloned my card, and I don't know, because you don't know, like there are n number of peoples are where the fraud can happen. But yeah, because of this big data analysis, so these things are getting stopped. Then in if we talk about telecommunication, so how you are going to churn your customer churn prevention, how you are going to prevent your customers. Network performance optimizations are there, or if so, let's say CDRs are analysis is getting used in a lot of criminal activities, case solving. So those are getting used. Or and then we have, if something in network failure is going to happen, so based on that, if we have got those data endpoints and data with us, so they can predict in advance, okay, this particular reason is going to have this much amount of issues within the network itself. So they can predict in future also, or if some failure is going to happen, so they can fix it before in hand. right? So these kind of these are some of the customer scenarios are there. Apart from this, let me give you an example of my latest project. So basically my organization is a logistic organization. My client is a logistic client who are dealing in you know basically UK's second largest partial delivery organizations are there. So these companies basically track their shipments at real time. So basically now previously they used to put the GPS locations, like wherever their trucks are there, shipments are there, and based on that they used to manage inventory and optimize delivery routes instantly. So which is reducing their cost by around 1 million pounds per year. You can think about like 1 million pounds per year using this big data technologies. And now they have also started using the events. Let's say if they are going to deliver to someone door and that person is not there, so they click the pictures, put the parcel there itself, and at the runtime they send it to the customer itself, like if the customer is not at the location itself. So yeah, so a lot of new things are coming, new processes are coming. Then another scenario we can take it as IoT and predictive. In IoTs, the sensors on basically the machinery, they can transmit the data and analyze in real time, so that the equipment should not get failed, and it should minimize the runtime. So basically this IoT sensors, as I told you, generally have used in most of the industry, especially when a flight is running. So at that point of time there should not be any issue with the flight itself. So these sensors predict the issues or failures that can happen in future. So they predict it beforehand itself. And social media sentiment analysis, like every lot of peoples are doing, and even Facebook, uh, every time they do the sentiment analysis, shares your pictures, whatever you did in last 10 years, your memories and all. Then these kind of things are coming up, and they are getting used. And apart from this, there are a lot of other very high, like Elon Musk is doing a lot of research on it. So his plan is to move to the Mars. So how they are doing it? So they are basically using the use of this big data only. From that data, real time data, historical data, analyzing those data and bringing the very fruitful results for the society. So this is how it is doing. Okay, so till here, if you have any questions, queries, please let me know.
Okay. No, Raj, I'm good.
Okay, it's clear, right?
Yeah.
Yeah, because right now we are just discussing about very common things, but
Yeah.
yeah, these are really going to be useful when we actually going to work. So if we have got these real-time scenarios, like how the data works, why we are using this, so that really helps to understand the problem statement and how we are going to resolve it, right? So these things really help. So now we are going to I'm going to tell you that how this big data evolve, like how it helped the organizations. So there was organization called Shares Holding Corporation. So previously they used to have traditional systems like Oracle's Exadata, Teradata, or SAS. They've used all. They were doing some sort of case studies on that. Like right now they were at that point of time they were working on huge data at that point of time. Let's say few terabytes of data. But what they seen is like they used to work on build these some of the feature predictions, or work on like how it's going to be what will be the size of the data down the line, let's say after 10 years or 20 years, what will be the size of the data at that point of time, whether our systems will be capable enough to handle that huge amount of load, because as they have seen the I showed you that graph where the data is exploding, right? So whether those systems will be capable enough to handle that huge amount of data. So for that purpose, they did a study, and using SAS, Oracle, Exadata, or Teradata, they did it for around 2 petabytes of data they have analyzed. And what they found, like, all those systems they were not able to process it. All got failed because this Teradata, Exadata, they are able to process some terabytes of data, few terabytes of data. But when it comes to petabytes of data, they all got failed. So then they have come up with some sort of solution which is called as Hadoop. So Hadoop was a term which was coined by some CTO was there. But how the concept of this Hadoop came was from some Google paper was there. Google file system was there. Based on that, they have created their own file system which is called as Hadoop, distributed file system. And they have used, this was for the storage, and for processing they have used it called MapReduce technology. So the combination of HDFS and MapReduce is actually the Hadoop. So which was the solution? But how this solution is working? Basically, the thing comes from here. Here, like how this Hadoop is able to handle this huge amount of data, how it is able to store that huge amount of data, and how we are able to process it. So for the Hadoop, basically, how the system works is basically, so this is how they have processed it. So for the storage layer, basically, they were using only storage grid. So first thing what they were doing is like they were collecting the data, storing it at the storage layer, and then finally from one layer to another layer they're moving it, right? So from moving from storage to processing, it was taking three main the issues that they were facing was like, you cannot get the same original data that you were getting for the processing that you are having at the storage layer, because when you are processing huge amount of data, like data in terms of petabytes, so there might be the case there are going to be some sort of network issues, and because of that you didn't get or during the transportation from storage to processing layer, some of the DR data got lost, or it got
Can you please repeat? Can you please repeat here? They collect the data and then they store it in grid and then they do
so
processing.
yeah. So
So
basically,
where's the problem
the,
here?
the problem is like how these traditional systems work. So basically, traditional systems were having their storage grid is different. Like they were storing the data somewhere and processing the data somewhere, right? Somewhere means it's not. It can be different locations can be there, or different systems are there. It can be the case like, okay, I'm having some storage server is there, and from that storage server, when I have to process it, so I'm moving that data to my processing layer, right? Because compute is going to be different, right?
Mhm.
So when we are moving the data from storage to processing, so they found three main issues. First thing, they are not able to get the same high fidelity raw data as they were having at the original site. Like the data got some sort of data is got corrupted during migration from storage to processing.
Okay.
Let's say, let me give you an example. Sometimes what happens is like a few kbs of a message that we are sending, when it comes to the from sender to receiver, when it comes to the receiver, so receiver got some encrypted data, right?
Mhm.
Encrypted message. So that message has been, it was just few kbs of message, and it got corrupted during the transition. Sender sent it to the receiver, and when receiver got the message, it didn't receive in the same way it was sent by the sender itself. So because during this transition from sender to receiver, there are some you can say some application was there, or some people are there that who are trying to store your data. So they try to capture that data, and because of that, they did it. They tried to encrypt or decrypt that data, and because of that, it got you didn't get the correct data. So similar way, it can happen. It happened in the system when you are moving your data from storage to processing, and that your data is in terms of 22 petabytes of data. So you can think about petabytes of data is 1 petabyte, 1024 terabytes, 1 terabyte is 1024 gigabytes of data. This much huge amount of data they were trying to send. Then the second problem is, like, again, during the migration, it's not the case like some of the data it got like lost during the transition from storage to ETL compute. Your data, like even it happens like we did some migration from Oracle to Databricks. So when we have migrated the data and when we were doing the reconciliation, we find that okay, at the Oracle side, I am having around 2 billion rows. Let's say in one table, I'm just talking about 2 billion rows. So the table size was around in few GBs itself. But when we migrated the same data to Databricks side, we lost around 2 million rows. So during transition itself, and now I'm talking about the current scenario itself, right? Now we are having still we lost, but when we are talking about this data itself during one processor, one system to the another system, so definitely it can cause these issues, and it could be there could be multiple reasons for that. Let's say some network failure is there or something else has happened, right? The third point is, premature data death. Premature data death means generally it happens because of the storage limitations that we are having. So, like when we are storing the data, it doesn't mean like it's going to be like for servers, it comes up with some lot of cost. So these servers are quite expensive. Like if I talk about Oracle's Exadata, so around let's say we are having a server with 20 terabytes of server is there. So I have to bring if another 20 terabytes of server. So it's going to cost me a lot, huge amount of money is involved in it. So what we do is like when we have to store this, we have to invest a lot of money. Otherwise, what we are doing is if it doesn't have. So what we used to do is like, let's say I can store up till last 5 years of data, and then I have to remove that data because of my storage issues. So once my data reached to that threshold, so automatically a lot of systems previously what they used to do is they used to remove their data automatically. Like in medical world also, they used to have only last 7 years of data. Once your data is older than 7 years, they automatically used to delete that data because of these storage issues. But now, because of this big data technology, now they are having the data even for last 30 years, 40 years, even 50 years of data they are able to store, because now the storage becomes quite cheap because of the invention of this big data, right? So these were the three main issues which really do have the limitations on our data analytics part. So how why we were having, because we have to move the data from storage to compute layer. So how big data has resolved this? So what they did is, because we were having the problem with the moving of the data. So what they did is, in Hadoop, what they did, wherever they are storing the data, they are computing at the same layer. So if we are not moving any data anywhere, then all the three main issues got resolved. If I don't have to move my data to any other layer, where I was storing my data at the same location, I'm just processing it. So what they did is they have moved to a they've just tested it at 300 node Hadoop cluster, which was able to, process their 100% of the data. So there was no issues with that. They were able to keep their data live forever, and they were able to have their whole 2 petabytes of data. There was no loss of data, because what in Hadoop, what we are doing is, wherever we are storing the data at the same layer, we are processing it. We are not moving our data for processing to another layer. Understood?
All right. Yeah.
Any issues, any concerns? Now, how Hadoop work, that we'll understand now, right? But for now, what the Hadoop is doing, wherever we are storing the data, but how Hadoop stores the data and compute it, we'll get to know. We'll go deep dive into it, because we have to understand this, because the same concept is now applicable as a part of the Spark, PySpark, whatever future technologies are going to be there, and what because currently we are thinking we are in Hadoop, but now when we talk about how after Hadoop, how Spark evolved. So, but the concept is same, that we are using as a part of Hadoop. They are, just you can say the optimizations are done, upgrades has been done, right? But still we use, storage for, at least Hadoop we are using for storage. Processing, we have moved from MapReduce to Spark. But again, if we see the principle behind the Spark, it is again the MapReduce itself, right? The concept is same, but as the technology is evolving, it has changed a lot, right?
Okay.
But the underlying principle is almost same, right? We'll talk about feature sessions. So now my Hadoop works on DFS, that is distributed file system concept, right? So previous traditional system, they used to work on, they were not using this distributed system. They were working on standard mechanism, which was, let's say, one machine is there. So Exadata, they are having huge, although the machine is very expensive, very huge hardware is there. They are using, let's say, 512 gigabytes of RAM, and 20 terabytes of storage was there. But still, it was happening on a one machine, right? Correct?
Yes.
We are just taking an example. Let's say we are having one machine which is having, let's say, 4 input-output channels. Each channel can process 100 MB per second. And then we are processing the same thing from 10 machines. So if we talk about reading 1 terabyte of data, and here we are reading the same 1 terabyte of data. So how much time one machine is taking? Definitely 10 machines which are processing that data in parallel. So definitely those will be able to do it quite fast, right?
Correct.
So it is just to understand the concept, right? So how DFS basically works. So in DFS, distributed file system, we are going to store the data onto multiple systems, and also we are processing it in the multiple systems. So how we are doing it? Let's say one machine is taking around 43 minutes, then 10 machines are going to take around 4.3 minutes. It's an average, right? We are just taking it because we are processing here the the machines configurations we have kept it same. We are just trying to understand that when we are processing from single machine or when we are processing from multiple machines, so what is going to be the impact, right? Although if we talk about, if we are saying, okay, no, but in traditional systems, we were having very good machines, which are not supposed to be, they are fault tolerant. Basically, they are not fault tolerant. Even you see in servers also, there are a lot of failures happens, right? So when you go to the bank, previously when you used to go to the bank and say, okay, I have to do some sort of transaction. So banks generally used to say, server down, we can't do it right now. You have to wait, right? So even servers get down, right? And even servers, those servers are not very, They are very high-end machines, very expensive machines, but still servers used to get down, right? So here what we are doing is, instead of processing from one machine, we are processing it, storing and processing from the multiple machines. So this is how we are doing as a part of DFS, distributed file system, right? So you can say it's taking around 4.3 minutes. Now, what is Hadoop? So here comes the concept of Hadoop. So Hadoop is basically a framework which allows for distributed processing of large data sets across cluster of commodity computers using a simple programming model. Now, here few terms are there. It's a framework which is used for distributed processing of large data. It means we are not processing from a single machine. In Hadoop, we are processing from multiple machines across cluster of commodity computers. Now, what is commodity computer? Comes here another term. So commodity computer is basically cheap hardware, very low cost hardware. Up again, and using simple programming model means programming model here we are talking about MapReduce for processing. Okay, so commodity computer means cheap hardware. So again, if we are talking about cheap hardware, so definitely it is going to be, there are the chances that they are going to be down very frequently. Yes. One thing is there, like when we are having high-end machines, servers are there. So definitely servers are very, less prone to, go down, and they don't go very easily down, but even they go down, but not very, frequently or easily. But yeah, commodity systems can go down, and they can be very, very frequently they can go down. So for that, we have another concept. So it's an open source data management with scale out, storage, and distributed processing. Now, there are two mechanisms. First thing is it was an open source data management was there, and it uses scale out storage mechanism and distributed processing. So have you any idea about what is scale out and scale in mechanisms? Have you ever heard this?
No.
term?
No.
Okay. So basically, there are two, we can say storage mechanisms are there when we have to scale in. So scale in basically used when we are basically, increasing the storage itself. Like it generally used to happen in terms of when we are doing it at the, server level. Let's say you previously I have a server which was having let's say 512 terabytes of gigabytes of RAM, and let's say 20 terabytes of storage. Now my storage is getting down, so what I will do is I'll try to add few more disks to the same system, right? Instead of 20, and let's say I did it for 22 25 terabytes likewise. And I have just increased the RAM to, let's say, from 512 to I did 600 or 700, whatever it is, right? But after that point of time, I cannot increase it. Why? Because I'm increasing the, let's say, RAM as well as hard disk, but it is going to, handle it up to certain level, because I'm having other, system also, like I've got the chipset, what chipset it is using. So if I have to change everything, then definitely it's better to get a new system, right? A better system. And if I have to get that better system, it is again going to incur a lot of cost, right? So this is my scaling mechanism, where I can scale up to a limit, certain limit is there. Another one is the scale out, or we also called it as scale horizontal, and scale in we also called it scale vertical, right? So in vertical we can go up to a certain limit. After that, we can have a simple example for vertical, scale vertical or scale in. Let's say we have got our mobile phones, just for an example. So if my mobile phone is get full for the storage and it's getting slow, so what I can do is I can increase its RAM, I can increase its storage, but up to a certain limit. It doesn't mean that I can double triple it, because my the chipset won't work on that. My current OS is not going to work on that. So a lot of other issues will come up. Similar issue is with the these systems itself. But what scale out mechanism or scale horizontal is that we are not only basically increasing the storage and processing. What we are doing is we are adding more number of systems. Let's say initially I have started with 10 systems, so I have added 10 more systems. I have added 20 more systems. I have added 30 more systems. Likewise, as per my requirement, and there is no limit. So if I talk about the Facebook or the these Amazon and Google, they are having even 20,000 clusters, 20,000 machines in just one cluster are there. They have got such huge amount of clusters are there, and they are working fine, right? So scale out mechanism storage means like we are just not only adding the just the hard disk. We are just adding the whole machines, so that is with storage we are also parallelizing the processing itself, and there is no limit. As I told you, even 20,000 clusters they have got been tested, and there is no issue, right? Any issues and concerns with this?
So in scale out, is there a scale horizontal and scale vertical?
Yeah, that's why I told you. Like in Hadoop,
So
we are doing scale horizontal, not vertical.
okay,
Vertical
so
basically was the traditional systems, right?
okay,
In vertical, we have got the limit, like up to a certain limit we can increase. But after that, my system won't support it, right? Even let's say my laptop is there, right? So I can increase its let's say initially my RAM was 8 GB. I can go up to 16 GB, but it doesn't mean that if I'm going to make it, let's say 32 GB, so I can put it 32 GB, but my 32 GB, my processor is not going to support it, right? Same way, if I have to increase my RAM hard disk, I can increase to up to twice or thrice. But after that, definitely other things are going to be get impacted, and it won't make any sense, right?
okay,
But in case of horizontal, we are not making the changes to that machine. We are just adding that similar machines to the system itself, right?
okay.
So basically, these are going to be the more four main key characteristics. First, we have already talked about the scalable, right?
Mm.
So we can scale horizontally. I have started with 100 machines, or let's say 10 machines, then I have added 10 more machines. I need, let's say, my requirement grown, so I have added 10 or 20 machines, whatever your requirement. Based on your requirement, you have started with 10 machine cluster, now you have got 100 machine cluster, right? So
Mhm.
you don't need to make much changes. And what you have to do is you have to just do some configuration changes and restart the system, and it will work, right? This is how it works.
Okay.
Then flexible, as I told you, it is traditional systems generally used to work on structured data formats, or up to some levels semi-structured data formats. But Hadoop is flexible enough that it can handle any file formats, or any different types of data, whether it's going to be structured, semi-structured, and structured. It will able to handle any kind of data. Then economical. Why we are saying economical? As I told you, here we are using commodity hardware. We are not using any high-end architecture. Then, as we have already discussed, like okay, we are using commodity hardware, but they are very prone to failures. So how it comes then reliable? So for that purpose, in Hadoop, by default, we are maintaining a fault tolerant or replication factor, which is going to be fault tolerant, and that is 3 by default. If I'm not defining any replication, so by default, Hadoop do it like whatever data I'm having at one machine, the similar data is also going to be replicated to two other machines, and those two machines can be at the same location or they can be at a different location, right? Based on the requirement, and that is again configurable. If I want, I can make it to 4 machines, 5 machines based on my, the criticality of the data. Like if I want, okay, my data is so critical and I want to make extra, cautious about my data, so I can store at 4 or 5 replications also. Let's say if my 1 replication is down, 2 replication is down, even 3 or 4 is down, so I will be able to get the data from the 5th replication. But 3 replications are more than enough. 99% of the, in cases, only this default replication works fine. It is quite, rare. Let's say if you have put your data in 3 replications and all that, 3 replications are on the same, let's say, server, same data center, and let's say something happened, like that data center is down, then definitely for that period of time, you won't get any data. For this purpose, what most of the organizations do is they used to put one data and its one replication at the same location, and the third, second replication at some other location. So in case, let's say, if your whole site is down, let's say your data center is down for some time, then you will be able to fetch the data from your remote location, right? Although
Okay.
there are going to be, some sort of cost involved in it, but yeah, for better. But if we are going to talk about in terms of the cost that we are having for, for the traditional systems, it is quite cheaper. And now this what we are trying to build here is mainly the, the data centers, which are we can say the physical data centers. Now these are also get replaced with the concept of cloud. Now even people don't want to invest this amount of money. They just go and get the, data storage and processing from the cloud itself, and they are just doing it. So we'll come to that point, but right now we are trying to understand some, the background. So that's why if you are thinking, like, if you're generally, because you must have got the idea about the client cloud and all, right? So you must be thinking why we are doing it, why we are doing it.
I have a question over here. Whenever we have physical infrastructure, physical storage devices, or physical data center, how we will move data from one location to another one?
Yeah, for that we are having, a lot of dedicated fiber networks are there, where there are negligible chances that your data is going to be lost, and that is the, data provider. Basically, it's on data provider. They only going to charge you once your data is finally migrated to your target. This
Okay.
is what they give you that 100% guarantee that your data is not going to be, in transit, it's not going to be lost at all. This is
And
the
earlier,
guarantee.
you were talking about this thing. This will cost us a lot if we'll increase the memory spaces or increase the storage devices. But now you are talking about this thing. We can create some replicas in the systems. So
Yes.
this will not give us an increase of costing
Yeah.
and all.
Yeah. This is what I was telling you. Let's say if you were because this the servers are quite expensive. Let me give you an example. The Oracle's Exadata, just for 500 terabytes of storage, it is going to cost you, let's say more than $100,000, a few $100,000. But if you are going to make the similar configuration on commodity systems, so it is going to cost you a lot of money. But with that, you are processing in parallel. So these 4, the advantages or the key characteristics I am telling you. So the same, all the characteristics are going to be introduced there itself, because there you are getting the flexibility, you are getting the reliability. Or let's say if you have brought the, you are working on the server itself, and server is down for, let's say, couple of hours, so that is going to cost you a lot, right? you see last year we had the failure at the Airtel side. If you remember, I think 2 years back, their system was down for 4 hours, so they lost around a few $1 million revenue, because for that 3 to 4 hours. Because why I remember is because one of my friend was involved in this, and their systems for all over, uh, for all Asia region, for the last 4 hours, whatever transactions the Airtel did, they were not able to capture a single transaction. So you can they lost around few million transactions data, and they were not able to handle this scenario. So this is how it happens. But if we are working on the Hadoop systems, so generally if you talk about the banks, so they are still they are using their mainframe systems. Still some of the banks, they have not migrated to other systems, because they want, okay, if our systems are going to be down, then they are going to lose huge amount of money, right? So this way it actually works. So yeah, it is economical as well as scalable, reliable, flexible. Understood? Any do I able to resolve your issue?
Yeah, it's clear.
Yeah. Yeah, so in this way, we basically, this Hadoop is able to achieve all these, features. So if we have to, now define what is Hadoop, then it's going to be like we are able to work with structured as well as, unstructured data, and it's using simple programming model. We'll talk about what is MapReduce, because it's going to be the base for our Spark also. Then we are using scale out rather than scale up mechanism. Here we are bringing code to the data rather than data to the code, because what I told you, like for processing, we are not moving our data. And yeah, one more point I just wanted to make it here. Let's say for processing, what is going to be the processing? What will be the size of the processing? Let's say if I'm writing a application to process any data, it can be in few MBs maximum, right? Because or maximum I can have, let's say, very huge application is there, so it's going to be in some GB, right? But it's not going to be more than that. It's not going to be more than that. But so that's why instead of moving our data, we are bringing the code to the data, and there we are processing it. So we are moving the processing, not the data. We are bringing code to the data and processing there itself. And because of this, just moving a few MBs of data or moving few petabytes of data, which is going to be cheaper and faster. Definitely MBs of data, right? So that's why we are just bringing code to the data rather than bringing data to the code. But in there itself, in traditional systems, what we are doing, we were just moving the data to the processing. But here the process is totally different, right? Then we are having high scalability, like whenever we want, we can scale up, and we'll get the like whenever, based on your demand. Like right now we have got if I talk about the cloud itself, so we have got on demand resources are available. So here the concept is, now this concept is same as high availability. Like now it's being handled by the service providers, cloud providers. Now at the time of Hadoop, when this cloud concept was not there, so people used to do it their own way by adding more machines to the cluster, and your data was available all the time. Then here we are using commodity hardware, so it's going because of this, it's cheaper and fault tolerant because of a replication factor, right? So by default we are maintaining 3, but if you want, we can again, it is configurable. So all these three are these whatever we are having, these are all configurable, and we have got some configuration files are there where we have to just change a few things, and we are able to do it very easily, right? Any questions, any queries so far?
I'm good. Right.
You can just let me know where you find okay it's going,
Sure.
so we can stop it there itself, because for me it's for me it's okay, this is not the first time that I'm doing it, so it's a practice for me. But
Okay.
yeah, if you feel okay now it's getting exhausted, so we can stop it there, because I want that you should have these concepts in your mind every time. So whenever
Okay.
something comes up, you should be able to correlate with it, and then you will be able to answer it confidently, as well as you will be able to understand the problem statement per se, right? Okay. So when it again comes to the Hadoop, so again now we need to check what are the differences, or what changes that we have seen as a part of traditional systems. So if we are talking about traditional systems, is generally the structured data sets. So generally we are talking about RDBMSs and then Hadoop. So what are the differences were there? So like in deep, you can think very we have already discussed all those things. So in RDBMS, we have got structured data, the data that we are having in terms of row and tables, row and columns. But in Hadoop, we are going to process multiple formats, multiple data types. So it can be structured, semi-structured, unstructured, any kind of data we are able to process. Then if we talk about processing, so here we have got limited or very less data processing is there. Limited in the sense that after a certain point of time we cannot process it. But here the processing is coupled with data itself. So wherever we have got the data, we are processing it there itself. Then governance, if we talk about here, we have got standards are defined for structured data sets only. But in Hadoop, it's loosely structured, means like if some new data format is going to become, so Hadoop is able to process it. It is able to accommodate it. Now we see like when we have just start our building the pipeline or framework for data processing, we have started with few data formats, like the data is coming from, let's say, Oracle side, and we have to move it to the to Databricks side, because I did a lot of data migrations, especially from Oracle to Databricks in last 3 to 4 years. I'm associated with this, so I did, I think, almost 12, 13 different data sources like Talent, HANA, then different RDBMS's data is coming from real-time sources, data is coming from batch, from it's coming from DB2, it's coming from RTT, it's coming from SAP HANA, it's coming from Alteryx. So yeah, multiple data sources, but initially we have started with getting the data from Oracle to, but when new sources are coming, so similar way, this Hadoop technology is able to evolve. Like whenever new things are coming, it's able to process it or adapt it. Now, next point is quite important to understand, schema. So when we talk about schema on write and schema on read, as I told you earlier also, like when we are when we have to write the data in a table, what is minimum required? You have worked upon SQL, right? You know SQL.
Yeah.
So what is the minimum requirement that you have? Let's say you have to you have to load a table in Databricks. Sorry, not in Databricks. Any of the not, we are not talking about Databricks now. Any of the let's say Oracle system, or let's say MySQL server or Postgres. Any of the database you can take it, right?
Hmm.
So you have to, let's say, insert 100 rows in a table. So how you will do that? What will be your requirement to insert those 100 rows into that table, so that those successfully get inserted into the table itself?
So we need to check the column matching, column names, and then data types.
Exactly.
Those things.
Yeah. So this is going to be, the schema on required on write means we need to validate the schema on when we are writing the table. Before writing the table, we should have table created, and within the table, what are the columns are there, what are their data types are there. Only then I will be able to, like, let's say I have just defined two columns, ID and name. ID are some numbers and my name is going to be some strings are there, right? So when I'm just writing it, like, I cannot say in ID I can just write Raj, and in name I'm writing 1234. Will it work? Definitely not. It will fail, because whatever data I'm having, the schema should match to that data. And if within one or two rows, if I'm having some sort of issues, then my insert is going to be fail at those records, right? So my schema validation is required when I'm writing the data. So before writing the data, my table should be in correct format. But in case of Hadoop, when we are writing the data, we are not checking anything. We are not doing any, checks. We are just putting the data, because my data is coming from different diverse data sources. Multiple formats are there. My data is coming in structured, semi-structured, unstructured format. And if I'm going to put schema on write in case of huge data set, then I won't be able to, even write the data, because my data is coming from diverse data sources. So there might be the case, there are issues with the data, there are noises with the data is not coming as our requirement, because the data is evolving every time, right? So in streaming data, if I talk about today, the data come up with, let's say, 10 columns. Tomorrow it is coming with 12 columns. Next day it is coming with 8 columns. Next day it is coming with 14 columns. So if I have already defined my schema, then it's not going to work, right? But when we are in Hadoop, we need to require the schema validation on read itself. So we have stored the data. However, in what format my data is coming, I've stored the data in my storage. When I'm just reading from that storage, then I am going to apply the rules on read itself. So that's why in Hadoop, we required schema validation on read, not on write. So that's why if we talk about RDBMS, reads are fast. Why? Because when we are reading the data, my schema is already validated, right? My table is clean. Data, I can have the wrong data, but at least my schema is clean, right? Only then I was able to write the data to the table. So when I'm reading it, it is going to be fast. But in Hadoop, writes are fast, because when we are writing the data, we are not checking anything. We are dumping the data as it is. But when we are reading out of it, at that point of time, I'm checking what data actually I'm reading, right? So this is how it works. Then, if we talk about cost, so RDBMS, I think no RDBMS is free. When we say, okay, MySQL is free, but that is only for limited tasks that we are doing. If we are using it at the enterprise level, so again it is going to cost you. You need licenses, at least for you need any sort of license for that. But in Hadoop, it's, as I told you, it's totally open source. But if you want, they can support you. So if you need, if you have to invest some sort of cost, so that is only for the support. But if you are able to do it by yourself, as it is open source, so even if you don't need any support, you don't need any cost to involved in it. Then resources, if we talk about here, we are already having some known entities are there. There's nothing that is going to be changed. And if you see in the last 20 years, nothing has changed. Everything is the SQL when it came. It is same as it is right now also, right? Then Hadoop, it's growing. Complexities are there. Whenever new things come, able to achieve, new complexities are coming up. So we are handling those complexities as per se. Now, then it comes like which is going to be best fit for what, like how we are going to use that. So in which scenario we have to use. So when it comes to online transaction processings, like online transactions where asset compliance transactions are there, operational data stores are there, where we are doing some live transactions are there. So still we are preferring to go with the RDBMS. Still, no organization is relying on even on big data, Spark, or real time analytics. Even we are saying like real time analytics, but it is still near to real time, because it's not like uh, when I'm getting the data at the same point of time, I'm able to process it. There is a gap, although it's going to be in few minutes gap is going to be there, few seconds gap is there, but gap is there, right? So that way we are still there on the RDBMS side when it comes to the online transactions processings are there. Hadoop, we are mainly using for data discovery, whenever we have to process unstructured data, massive amount of data is there, or OLAP kind of data, online analytical processing of data, like when we have to find out the insights from the data itself, when we are dealing with, let's say, 10 years, 20 years, 30 years of data, or likewise we have to process the data in that way, then we are going to use this Hadoop technology. Clear? Any questions on any of the points? If you
What is this OLAP?
OLAP is online analytical processing, like historical data. We need to find out the it's not the real time data. Let's say last 5 years, 10 years of data.
It's a historical data.
What?
Oh, it's a historical data.
Yeah, it's well, from now onwards to the last 10 years, 20 years. It could be anything. 1 year, 2 year, 3 year, 4 year. That is going to be OLAP kind of data. But OLTP is that what is happening currently, like what your transactions are going to happen. So it's still like banks, they are still using RDBMS is only for transaction. Although for let's say I have to analyze last 10 years of transaction, what was the pattern, or if we want to get the highlight inside of that data, then we are going to use Hadoop, but not on the current data itself. Current in the sense now onwards, we are not processing in that data using Hadoop. But if we talk about the latest technologies, like we are using the streaming data and all, we are processing the data at the runtime also. But as a part of Hadoop, we don't use that. But now, if you talk about, we are processing it, but still we are not processing the transactions data using latest technologies also as of now. Although a lot of banks, they have now moving to even to the cloud itself, but still they are most of the banks, especially in India, they are reluctant to go still on the to this cloud side itself. Like if I talk about the Barclays or JP Morgan, they are really working on this big data technologies or latest cloud technologies. But still, if it comes to their online transaction processings, they are still not using this RDB. They are still using this RDBMS, right?
Okay.
Okay. So this is Hadoop ecosystem. You want me to go ahead, or we can stop it here for today?
Yeah, I think we can stop it here.
Okay. Okay. Fine. Let's see. Okay, then I'll just I will share you these PPTs. You can just go through it just for your
Sure. Sure. Yeah, so lots of terminologies I have to look at
Yeah,
it. So
right. Because from next session onwards, we will be mainly, right. Today we have just discussed some overview, generalized things, Now we'll start moving into the Hadoop ecosystem. What are the different tools that we use and we used to use? Nowadays the some of the tools has changed, so I'll just walk you through all those two things too. Right
So still,
now,
how many left? How many pages left in this PPT?
I think for this, it's not about pages, but it's about the concepts basically. So these concepts are
Right.
really, yeah. This is how the this is the architecture works.
Okay.
So we'll because architecture is going to take some time, around 30 to 40 minutes, to make you understand each and everything in detail, right? Then once you are able to understand this Hadoop architecture, then things are going to be very easy onwards, right?
Okay. Okay. Tomorrow you will be joining at the same time, right?
Yeah.
Okay. Okay. We'll see the architecture from the architecture tomorrow then.
Yeah, and if you want, you can just go through the like if you got some time, so you can also go through some. You can Google it and see how it works. So that when I'm going to tell you those things, so it will be easier for you to understand,
Okay.
right?
Okay.
Yeah,
Share me the PPT.
yeah, I'll do that.
Yeah.